in last physics class we have done, that is that is properties of Coulomb's law. Now in properties of Coulomb's law, the last property that is given, that the net force acting on a charge Q due to number of forces Q1, Q2, Q3. That is what? Vector sum of all the forces. Vector sum of all the forces acting on it. So that is F vector equal to F1 vector plus F2 vector plus F3 vector. So based on this, we have to do some numericals. Now first numerical I will tell, see here. Suppose there are three charges of 1 microcoulomb each, separated by a distance of 10 centimeter. This is an equilateral triangle. This is A, B, C. In question it is said that determine the net force acting on A. Now see here, three charges of 1 microcoulomb each are placed at A, B and C. We have to determine the net force acting at A. So what we are doing here, let's see what we are doing here. We have to determine the net force acting on A. So we will fix the charges of B and C. That means charge B and C cannot move. We are just tying it up. Okay. Now you see, due to B, there will be repulsive force between A and B. This charge I have not bounded. Okay. So this charge is free to move. Suppose we have to find the net force acting on A. That is why we are considering that the charge on B and C cannot move, and this is free to move. Now you just see, due to B, there will be repulsive force between A and B. This is unable to move. Then there is what? Repulsion, and due to repulsion, A will move along this direction. So one force is F1 here. Follow? Again, here is 1 microcoulomb charge. This is also 1 microcoulomb charge. 1 microcoulomb charge. And again there will be repulsive force between B, A and C. This is unable to move. So this charge, where it will move? It will move along this direction by repulsion. So this one is F2. This is F1, this one is F2. This is, as it is an equilateral triangle, this angle is 60 degrees. So this will be also 60 degrees. Now we have to find a net force acting on A. So net force acting on A, that is what? Due to these two charges. So we can apply net force acting on A, that is F equal to root over F1 square F plus F2 square plus 2 F1 F2 cos 60 degree. Okay. Now F1, that is K into 1 microcoulomb into 1 microcoulomb by 10 centimeter square. K, that is 9 into 10 to the power 9, 1 into 10 to the power minus 6, 1 into 10 to the power minus 6 by 10 by 100 meter, the whole square is Coulomb. So here you are getting 9 into 10 to the power minus 3 by, this is 1 by 100. You are getting 0.9 Newton, that is force F1. Similarly, F2, that is also same, that is there. K into 1 microcoulomb into 1 microcoulomb by 10 centimeter, the whole square. And you again, here you will get 0.9. Same data is there. Now, resultant force F. Resultant force F, that is root over F1 square plus F2 square plus 2 F1 F2 cos 60, or this is F1 square is 0.9 the whole square, 0.9 the whole square plus 2 F1 is 0.9 into 0.9 into 1 by 2. So these two will cancel out. So you are getting 0.9 the whole square, 0.9 the whole square, 0.9 the whole square. So 0.9 common, you will get 1 plus 1 plus 1, that is 0.9 root 3. This is the net force acting on A. So here, that net force acting on A, see here, F1 is acting along this direction, F2 along that direction. Angle between F1 and F2 is 60 degree. So resultant force F, that is equal to F1 square plus F2 square plus 2 F1 F2 cos 60, and then we are determining F1 F2 and then the resultant force. Next, one more question we write down. Determine the net force. Again, determine the net force acting on A, and the changes will be, here it is minus 1 microcoulomb. Okay, this one is A, this one is 1 microcoulomb. You have to find the net force acting on A. This is the second question. Okay, you have to write it again. Just see here. Second question, net force acting on A. A is 1 microcoulomb, B is 1 microcoulomb, C is minus 1 microcoulomb. Now, as we have to determine the net force acting on A, only difference is that the sign of C has been changed to minus 1 microcoulomb. So, as we have to determine net force acting on A, we will wind up what? We will bound this one, B and C. That means B and C will not move. Now, you see, due to B, there will be what? Repulsive force between A and B. So, this will, one force F1 will act along this direction. Okay. Now, due to A and C, what will be that? See here, there is attractive force between A and C. So, this 1 microcoulomb charge will be attracted towards C. So, it will come along this direction. So, the force will here will be F2. Now, we have to find this angle between F1 and F2. So, here it is, as it is an equilateral triangle, this angle is 60 degree, this angle will be what? 120 degree. So, the resultant force F will be what? F1 square plus F2 square plus 2 F1 F2, 120 degree. We are determining F1. You are getting what? 0.9. F2 is again 0.9. This is cos 120 degree. And value of cos 120, that is what? Minus 1 by 2. So this will cancel out. This is minus 0.9 the whole square. These two will cancel out. Here you are getting root over 0.9 the whole square, that is 0.9 meter. Alright. So this is one sum based on resultant force. Next, just see here. Okay. One more sum related to this. See here. This is Q1, Q2, this is Q3. Q1 is given to be 1 microcoulomb. Q2, that is 3 microcoulomb. Q2 is, okay, 3 Q2, that is 2 microcoulomb. This is, question is determine net force acting on Q2. This distance is given to be 10 centimeter. This one is given to be 20 centimeter. Now see here. Here you have to find the net force acting on Q2. So we will tie these two, Q1 and Q3. So net force acting on Q2 due to Q1. So there will be repulsive force between Q1 and Q2. As such, it will be repelled along this direction, that is F1. Second force, that will be repulsive force between Q2 and Q3. So this will be pushed upward. So what is the angle between these two? 90 degree. So resultant force F, that is equal to what? Root over F1 square plus F2 square plus 2 F1 F2 cos 90. Cos 90, that is 0. So this is F1 square plus F2 square. Now we can find F1 and F2 and then put the values. F1 you can find out K Q1 Q2 by R square. 9 into 10 to the power 9. Q1, that is 1 into 10 to the power minus 6. 2 into Q2, that is 2 into 10 to the power minus 6 by 10 by 100 the whole square. So this is 9 into 2, 18 into 10 to the power minus 3 by 1 by 100 equal to 1.8. Again, F2, that is F2 is K Q1 Q2 Q3 by R square, 9 into 10 to the power 9. Q2, that is 2 into 10 to the power minus 6. Q3 is 3 into 10 to the power minus 6 by R. R, that is 20 centimeters. So this can be written as 20 by 100 the whole square. 9 into 2, 18. 18 into 3, 54. 54 into 10 to the power minus 3. And this one is 5. So 1 by 25. So 54 into 25 into 10 to the power minus 3 Newton. Now you can put the values. F equal to, you can put it. Okay. So this is related to 90 degree. Previous was related to 120 degree. Now one more simple sum you will get here. See here. This one is 4 microcoulomb. Now 4 charges are kept at A, B, C and D. What we have to find out? Number 1, they are at equal distance. Okay. And each distance, that is equal to what? 10 centimeter. All are 10 centimeter. What we have to find out? Determine the net force at D and C due to A and B. Okay, we have to find the net force acting at D and C due to A and B only. Okay. Now, it is better we will put it here. Leave it. There are net force acting on at D due to A and B. Now see here, we have to find a net force acting on D. So we will just tie this one so that it cannot move. Now there is repulsive force between A and D. So as it is, see this, we have to find a net force acting at D. So D is charge, D is free to move. So there is what? Repulsive force between A and D. So force will move along this direction. Okay. Again, between B and D, there is what? Attractive force between B and D. So this 4 microcoulomb charge will be attracted towards B. Again, the force will act along the same direction. So what will have a net force that is equal to what? F1 plus F2. You can determine F1, you can determine F2, just put it here. Okay. So this part will be homework. Next here, this is A, B, one more charge, I am keeping it here, C, 2 microcoulomb minus 1 microcoulomb, this is 3 microcoulomb. This distance, take it as 10 centimeter only we will take. Find the net force acting on C. Net force acting on C. So here we have to find net force acting on C. Due to A, there will be what? Repulsive force between A and C. So first of all, we have to find net force acting on C. That means what? We will tie these two A and B so that A and B charge is unable to move. Now there is repulsive force between A and C. So the force acting on C due to A. I am just indicating force acting on C due to A along this direction. Now due to B and C, there will be what? This will be attracted along this direction. So force acting on C due to B, that will be attractive. So here net force that will be equal to what? Force acting on C due to B minus force acting on C due to, they are in opposite direction, so you have to subtract. Okay. Next, one more important point, that is write down two charges of two charges of 4 microcoulomb. I am writing the question. Two charges of 4 microcoulomb and 9 microcoulomb are separated by a distance of 10 centimeter. Where should a third charge be placed so that net force is 0. Also determine the nature and magnitude of third charge. Okay. We will determine the nature and magnitude of the third charge. Now see here, two charges of one is of 4 microcoulomb, second one is of 9 microcoulomb. They are separated by a distance of 10 centimeter. Now it is said that where should a third charge be placed so that the net force is 0. So let the third charge be placed at a distance x from A at a point C, let it be Q. As it is separated by a distance of 10 centimeter, if this one is x, this will be 10 minus x. Now as the net force is 0, force acting on C due to A, that should be equal to force acting on C due to B. Whatever force is acting on C due to A, that should be equal to force acting on C due to B. Then only they will be equal and net force will be 0. So here, force that is K, Q1 that is 4 microcoulomb, Q2 that is Q by x square equal to K 9 microcoulomb, Q2 that is Q by 10 minus x the whole square. Q and Q will cancel out, K and K will cancel out. 4 microcoulomb into 10 minus x the whole square equal to 9 microcoulomb into x square. This microcoulomb will cancel out. Now here, don't break this one. See here. 4, this is 10 minus x the whole square equal to what? 9x square. Whenever you are getting here, don't break this one, just find a square root. So you will get 2 into 10 minus x equal to plus or minus 3x. So 2 into 10 minus x equal to 3x. 2 into 10 minus x equal to minus 3x. 20 minus 2x equal to 3x. 20 equal to 5x, x equal to 4. Here, 20 minus 2x equal to minus 3x. 20 equal to minus x. X equal to minus 20. So here, as these are two positive charges, we will take x equal to 4. Okay. So here, it will be situated at a distance of 4 centimeter. Remember that. This x equal to minus 20 we are not taking. Why we are not taking? Because both are of same charge. 9 microcoulomb and 4 microcoulomb, that is of same charge. If it was that one is positive, second one is negative, then we have to take the negative sign. Okay. But as both the charges are same, that is both the charges are same in nature, that is why we are taking x equal to 4, that is in between the charges. Okay. First part is over. So you are getting x equal to 4. Okay. And this part, this is 10 minus x, 6. Now we will come to the second part. First part we have determined the position. Now in second part we will determine the nature and magnitude of the charge. Now see here, for that, how to find the nature and magnitude of charge? Now as the net force is 0 at C, now between A and B there is what? Repulsive force. So we will come here, come to B. Now force acting on B due to A, that is repulsive force, which will be towards light. Now as the net force is 0, equal and opposite attractive force on B should act due to C. See here. First of all, we have determined the position. Second case, what we are doing here? See here. We are coming to one end, that is B. Now there is repulsive force between A and B. So the repulsive force acting on B due to A, that will be towards light. Okay. Now an equal and opposite attractive force should be towards B. Means just equal and opposite attractive force should be there due to C, so that the net force is 0. Okay, so we write like this: force acting on B, repulsive force acting on B due to A. Here I am writing repulsive force acting on B due to A, that is equal and opposite to the attractive force acting on B due to C. Attractive force, that is why we have taken minus sign. Okay. So repulsive force between B and A, that is K 4 microcoulomb into 9 microcoulomb by distance between A and B is 10 centimeters, 10 centimeter the whole square, equal to K between B and C, Q into 9 microcoulomb, 1 minus sign is also there, minus K Q 9 microcoulomb by distance is what? 6 centimeter the whole square. 9 microcoulomb will cancel out. K and K will cancel out. This is 4 by 100 centimeter square equal to minus Q by 36 centimeter square. This will cancel out. Q equal to minus 4 into 36 by 100 or 100 microcoulomb it is, or Q, that is equal to minus 1.44 microcoulomb. Remember, this sum is very much important. So here first part we are determining the position, second part to determine the nature and magnitude of charge we have to move to B. Whatever is the repulsive force acting on B due to A, same amount of equal and opposite attractive force would act on B due to C. So here that is why we have taken minus sign, and then on equating we are getting value of Q, that is minus 1.44 microcoulomb. Okay. Now remember one more important thing, that if suppose we are taking this one as Q1, this one is Q2. If Q1 and Q2 are of same sign, charge is in between the two charges. If Q1 and Q2 are of opposite sign, if Q1 and Q2 are of opposite sign, then third charge is outside the line joining two charges. Then here sign, if Q1 and Q2 are of same sign, then you write down then third charge. Okay. So if they are of same sign, the third charge will be in between them. If it is of opposite sign, then the third charge will be outside the line joining the two charges. Just I am showing here. Suppose in this sum, as we have done, this was 4 microcoulomb. Here it is 9 microcoulomb. Now, both are of same charge, same nature. Both the charges are of same nature. That is why here third charge is placed at this position. That is x equal to what? 4 centimeter we got. Now, by the way, if This is minus 4 microcoulomb. This is 9 microcoulomb. Then we got two answers, x equal to 4 and x equal to minus 20. Then we will opt for what? Second answer, that is negative 1 minus 20. So q, suppose q is here. So x is minus 20 means what? This is positive side. Minus 20 means it will be somewhere here. Third charge should be placed here, not here. Outside the line joining the two charges. Remember, this is very much important. If the two charges are of same sign, then the third charge where the net force will be, that will be in between the two charges. If the charges are of opposite sign, the third charge will be outside the two charges. Okay? Okay. Okay, till now, okay, do the sums. Till now we will stop here only. Okay.